backwards. There, I said it. I said I had it backwards and everything. Let me find it. We can screen share it. I'll share RJ's attempt since he's still angry, but he's just getting over it now. Maybe I should try my own preview.
In the vector laws?
Yeah, so it's the vector laws preview.
Yeah, that one was like, why is it this answer?
For which one? For the first preamble or second one, Megan?
So it's the vector laws preamble. So this one, which one's equal to u plus v? And the answer is
C.
W, even though B kind of looks right. And RJ didn't pick B either. Nobody did. Okay, let's look at the next one. Does u plus v equal v plus u? And the answer is yeah, it does. So,
Uh-oh, I don't have any chalk. No, I have chalk.
Stop from screen sharing, so I can't see what you're doing.
oh, well, thank you for being so polite about that. Well, I didn't want you watching while I was messily drawing on the board. Yeah, thanks, RJ.
Virtually, RJ, that is just the back of his computer. I cannot see anything.
So there we go. This is actually called the Parallelogram Law. So there's u plus v right there. And here we go with v. Well, it's rather crudely drawn. So there's v plus u. And so it's called the Parallelogram Law because when you're drawing these as vectors, you end up with a parallelogram. And so, oh, there's Luke. How are you doing, Luke? Good.
I'm good.
We were just discussing my wrongness in the. I had a preamble up.
Oh.
So RJ was victorious, and then of course I did the thing where I corrected it and didn't screen share. So far you've just missed nothing but completely embarrassing stuff. So it's been good. Here, I'll show you what the preamble looks like for a second, Luke. So I'm going to screen share, and I'm going to forget that I'm screen sharing.
And apparently I'm not nice when I tell him, so you have to let him know when he forgets.
I never know. I forget to tell them.
I did tell you.
Luke's too polite. Okay, so Luke, hey, you haven't done this, so we'll actually run this by you and see if you can see it first of all. So there's a bunch of vectors. I'm screen sharing, right?
Yeah. Yeah. Yes.
Okay.
1 second. My dad's going to go on.
Okay. So Luke, the question is, which of those vectors is u plus v?
Which of those vectors is a plus b?
U plus v.
B?
B? Well, actually, if you take a look, it's rather fiendishly designed to make it look like it should be B. But if you were actually to put U tip to tail with, if you were to put V tip to tail with U, you actually end up here at this position. So the actual answer is W. So when you're adding them together, you put them tip to tail, and that's called the triangle law.
Okay.
Okay? And then we go to this one, and the question is, do you think that U plus V, so this is an example of the way the triangle law, you think that U plus V gets you the same result if you did V plus V plus U? So let me rephrase. Is U plus V equal to V plus U.
Yeah, but it's not the same direction or anything, is it? Like,
It actually, so that's as far as we got. So look, I'm gonna actually stop the screen sharing. Oh, wait. And then there. Okay. So this is called our parallelogram law. So this is U plus V, done in that order. And there's the result. Our vector U plus V is this single result. If I do it the other way around, in other words, I do V first, and then I add U to it, basically it makes a parallelogram, but I wind up with the exact same resultant vector. So this is called the parallelogram law. What it really means is I can just add those vectors in any order, and the resultant vector is going to end up being the same. Okay. Last question. I'm going to start screen sharing again. Okay. So this is the one. This is the one I had wrong. So, as you can see, we have U, and we can have V, and here's the resulting vector U plus V. So the question is the magnitude of the vector U plus V, in other words, that one, greater than or equal to the magnitude of this vector plus the magnitude of that vector? Meg, what do you think?
Sorry, I think no.
You are correct. Of course, you've done this already, so it helps a lot.
Yeah.
Okay, so, oh, we don't have the general feedback. So, this is called the triangle inequality, and it seems really silly, but basically all it says is the two sides of a triangle are always going to be longer than or possibly equal to this third side of the triangle. And it actually just makes sense if you think about it. Okay. Does that make sense, Luke?
yeah, it does.
Yeah. So that's called the triangle inequality, and that's about all there is to that. Now, a lot of what remains is this is kind of a pretty simple introduction. Did you get a chance to look at the first unit, Luke? I think it was called Introduction to Vectors.
Is that the first preamble? That was there?
Yeah, like that whole first unit where they just went over the vectors. Oh, it just disappeared. Okay.
There's nothing in the first lesson.
Oh, there's nothing in the first lesson?
No.
Okay.
I miss those chairs with the chamber.
Sorry about that.
Yeah, no problem. I was just wondering if you'd done the first lesson, the Introduction to Vectors, from the CEMC site. And then Megan just told me that there's nothing there, so.
The vector concepts one? Yeah.
Yeah.
The attempt quiz now, it goes to, cannot start an attempt at this quiz. This quiz is set to be graded out of 10, but none of the questions in the quiz have grades. Can be fixed on the edit quiz page.
All right.
Not our fault.
Oh, well, no, let's not go allocating blame here.
You don't have a problem with it.
What's that? Okay. So there we go. The question is, what's A plus B minus C. So we start to understand how to add vectors, right? How do we subtract them? Any suggestions, RJ?
Add the negative.
Add the negative, that's
or
right,
opposite direction.
exactly. And so, in this case, what it would wind up looking like, sorry, I'll try and get this to scale, A, B, and minus C. So, oh man, they overlap. Par for the course today. So to subtract, you just add the opposite or the negative vector.
Excuse the interruption, please. Ms. McClay's grade 1-2 class would like to extend an invitation to all students and staff to make sure they go out to the garden and pick up their free tree saplings. They need to be planted as soon as possible, so you should make sure you get out there today and take them away and get them planted in the ground. Thank you.
Someone want to get me a tree?
Yeah, do you want a tree, Luke?
I'd take a tree.
You really want to train?
Actually, coming into town soon.
Was that right?
Yeah, couldn't get a tree.
Luke was doing lawn care all yesterday, so he's probably seen enough tree planting for a little while.
I was cutting glass today too earlier.
Was that right? Yeah. Finally growing.
Yeah.
Okay, everybody. Tough one.
I have a,
Yes. That's what makes it hard. It's tough to pronounce.
just a random.
Okay. This is really hard.
So is that saying A has two directions?
Yes, it does.
So this is actually a vertex.
Oh, I know.
So,
Oh, okay.
yeah,
Okay,
so
gotcha.
in this case, notice in these we're denoting our vectors as lowercase numbers. In this case, we're stating them based on the beginning point and the end point. Okay, so yes, there are the two notations that you use for vectors. So when it says vector AB, it means starting here at A and ending up here at B. Okay, so yeah, it's a little confusing, but not too bad when you realize uppercase, lowercase. So, on 3, everybody say what vector is equivalent to AB plus BQ plus QF. Ready? 1, 2, 3.
I waited a little second.
Okay, I think everybody except Luke said AF.
Not everybody.
Yeah, just enough with at the end.
Yeah, so AF is equivalent. Okay. Everybody's good with that?
Bueno.
Okay, it gets harder. It's gonna get harder.
I don't know.
So we've got two vectors, M and N, and they are unit vectors. And if I say unit vector, do you know what that means? RJ is nodding his head yes. What does it mean, RJ?
They only travel one unit.
They have a magnitude of one unit. Yes, that's right. The magnitude of m is 1, and the magnitude of n is 1. So that's the definition of unit vector. Okay. They're at a 45-degree angle from each other. And so that means when we put them tail to tail, they're going to be 45 degrees. What we want to do is we want to find the length of 4 times m. Sorry, 4 times m is in mangrove plus 7 times n. And so in each case, we're multiplying each of these unit vectors by a scalar. And we're going to end up with a triangle. Or we could even make a parallelogram.
So are we trying to find the other side, or are we trying to find somewhere?
So we're trying to find,
Oh, that would be the other
yeah,
side.
so we're finding the other side of the triangle, that's right.
Isn't that two possible answers?
Well, let's think about this.
Oh, no, it's not, no.
Let's see, would that work?
I think it's
It-
5 or
I don't know if it properly works, but.
There are a couple of approaches that you could actually take with this, aren't there?
Well, there's a very easy one, which means I don't know if those numbers actually work properly, but.
Okay, so here we go. So there's 4m. There's 7n.
Alright, guys, not that much.
There's our triangle here, and we can do this in either order.
That's why I don't think the numbers work.
You don't think the numbers work?
No, 7-9 is too big, I think.
Okay. So we unfortunately do not have a right angle triangle here.
Really good.
Actually, we could, couldn't we?
Yeah, that's what I was thinking. It's a 45-degree angle, which means you could make an isosceles triangle, which means the other side would be 4m. But 7m is too long.
Yeah. Okay. How long is this side?
7m,
This is 7 units. How long is this side?
4.
4 units, because these are unit vectors. And what's this angle in here?
45, 20, 9.
135.
135. Yeah, that's right. And this is the one that we've got to find here. So this is 4m plus 7n. Anybody care to guess what law that is?
For the angles?
To find the length of that side. 4m plus
You
7n.
can use cosine
We can use the cosine law, that's right.
or tangent law, whatever. Not putting the directions in there.
Oh, not putting the arrow on the vectors? I guess I should.
Can it be 4n? Can it be 4n?
And there's some chicken fingers up there, it's awesome. Yep.
Yeah. No, I just wondered if there were some chicken fingers around.
I think so.
Pretty awesome.
I have burnt chicken fingers in the fridge.
Go for some right now.
Okay. Hey, what's this one?
16 inch square.
So yeah, it's just a length, right? So, yep, 16 plus 49 plus 2 times 4 times 7 times cosine of 135, which is going to be negative 1 over root 2.
Yeah, it's negative. It's, yeah, it would be. It's negative 7.07.
Okay. Who can calculate that one for me? Because I don't want to do it.
7 times 4 is 28 times
56. So, and then divided by the square root of 2.
$85.5?
Oh, you have,
Oh, negative 8.
yeah. So,
Wait, oh, hold up. I did that backwards. Just a second. Negative 14?
no, that seems,
1959?
so that's 8. 7 times 8 is 56. Divided by the square root of 2.
It's
Oh, wait.
39.6.
I keep doing it wrong.
60.
Terrible. What is happening?
What'd you get?
In my calculator.
What'd you get, Luke?
I got 25, but I just, we kind of do it.
Wait, are you asking for the total or just?
Yeah, right now we're,
Got
Why do you
25 as
Why do
well.
you have 39? Where did you get 39?
oh, I thought I heard a 39.
No.
No one said 39.
No.
Well, this is
Oh,
about,
I said that's for the, all that multiplication comes to 39.6.
Oh, okay, all right.
Yeah.
It's 25.
25? Okay, so,
How is it 25? 16, oh wait, oh, that's a negative, right? That's where I went.
okay. So now we're just going to use some properties of vectors. So there, we've got m, and it's equal to 2 times vector A plus 3 times vector B. We have n, and that's just equal to vector A. Minus 4 times vector B. So what we're going to do is we're going to find 2 times n, subtract n, and we're going to find it in terms of A and B.
Okay,
We'll
Maybe
see.
it's a new question.
We'll see. What's that? This is a new question, yeah. So this doesn't involve any magnitudes or weird triangles or anything. We're just basically doing some simplification.
is it minus or plus?
Right there?
Yeah,
Oh,
keep
that's
sending away.
that's a minus. Yeah. This is an and.
Briar Smith, come to the office, please.
What'd you get, Luke?
Me or anyone?
Anybody? What'd you get, RJ? 3A plus 10B. Meg, what'd you get?
I got,
Luke, you got that?
yes,
Meg, you got that?
yeah,
Okay.
I had the wrong thing, but I'm good. Yeah, that's what I got.
Okay. Outstanding. Okay. I think that's it. What I'm going to do, let's just really quickly, we'll go do some quizzes and see if we get it right. So ready? I'm about to screen share,
Dun, dun, dun.
and sometimes a failure at it. Remind me later, AVG. Okay. There we go. Okay. Can everybody
Oh,
see?
it's color coordinated.
Yeah, isn't that pretty?
No, I just see it.
How fancy.
Yeah. Okay. We'll leave this one up to, this one's going to go out to Megan. Which one of those is negative V?
The third one.
The third one over. How did I do? Or
Yeah.
doesn't say how did Megan do.
How did you do?
Hey,
If I got that wrong, it's on you.
says
Good job.
All right. Ready? Let's see if they get any harder. Oh, jeepers.
Yes, that's the easy one.
Negative R. Determine the single positive vector that is the result of that.
Yep.
Wow.
That's gross.
Yeah. Yeah, I'd say.
It goes from, what is the negative of this?
RQ.
Bam.
I still can't see it.
What's that?
I still can't see it. I just see your like your blue plus.
Oh, you can't see it?
I can see it.
Okay. RJ's hallucinating.
Or do you just really weird?
There we go.
Okay, so
Didn't want to.
so what we need to do is we need to draw out. I think we need to draw out a quadrilateral. So we need to draw out PQ, R. Is it even a quadrilateral? PQ, R.
It is.
That's a quadrilateral.
The
Okay.
answer is like P.
Do we need to draw it out, or can you just like take each letter and subtract or add it to itself?
Ooh, that's a good
So
question.
like there's a negative Q and there's a positive Q, so that means there's no Q in our vector arrow answer thing. That's what it meant. In the vector, that's the answer.
Okay,
So like, and there's a negative S and a positive S.
PQ, and then there's going to be an R here.
You're still screen sharing, so you don't know what you're writing on the board.
Yes, yes,
I can hear you writing on the chalkboard.
that's enough. What's that, Luke?
I just brought a friend to help me out.
Oh, okay, all right. Well, that's good. We could use some help. Now we've got a T here. This is more than. So you've got phone a friend system going on.
That's my logic.
That's what I would say too, Arj. Or TP. Toilet paper.
No,
Or you guys.
because
So we got SR.
nothing goes from T, so it has to go to T. It
Everything has to go to T.
Like, there's one P
Oh, yeah,
and one T,
TP.
and it starts at, P is at the start and T is at the end of one, so it's P to T.
Try PT. From
Oh, okay.
Because if you take the negatives and make them positive, you just reverse them. So you have a Q on the front and a Q on the back, so it's connected somewhere, so it's not the end. There's an R at the beginning and
So RJ, you're doing a lot of talking. What's the answer?
PT.
Okay.
PT. I agree with right there.
PT.
My logic is in the chat.
Let's see.
Not saying anymore.
Go RJ.
Woo! Mine didn't update.
Was that right?
Mine didn't.
Okay.
Beautiful.
I get to school there now.
Okay. Here we go. Could be the internet.
Can we run laptop?
Everything else is actually pretty easy. Okay. So number 5. Number 5 is just this is going to be another one of those you have to make a triangle, and you're going to need to use like cosine law. Yep. So for homework, let's just do number 5. Try number 6. We'll take that one up tomorrow, or at least we'll talk about it. And yeah, let's do 5, 6, 7, and 8. So you missed out, Luke. We went to the hyperbaric chamber in Tobermory this morning.
Oh, where was that?
So that's like for diving, for scuba divers, if they ascend too fast, nitrogen gas bubbles out of their blood and potentially kills them. So they're building a new one. We went up and the doctor up there gave us a big tour of the facility. Sometimes he actually takes you down, like he puts you in and pressurizes it and everything like that. But
That's pretty cool.
actually, it's really cool. The guy's name is Dr. Harper. He was actually an astronaut in the Canadian space program before it got canceled back in the 60s. So he's done a lot of work with like high pressure, high altitude medicine and stuff like that. So yeah, it's pretty cool. But,
I did like a project on scuba diving, like big 11 chemistry, I think.
oh, is that right?
All those, yeah, that stuff. So That's pretty cool.
He talked about nitrogen narcosis, and
Yeah.
he quite often goes on and talks about like the blood gas or the gas mixtures, the heliox, and all that sort of stuff. So yeah, it's actually pretty good. We should have invited you.
Yeah, maybe we'll drive.
Yeah, that would have been a drive and a half.
You guys have nice stuff.
Yeah, RJ was a reluctant participant.
I got the ride Wednesday.
Okay, so are you able to come tomorrow, Luke? Or are you at work or?
Are we working tomorrow? Yeah, I can maybe make it. I'll try tomorrow.
Okay, all right.
Sorry, I'm in a rush here.
Yeah, no problem. We'll see you maybe tomorrow or maybe Monday.
Yeah, sounds good. I'll let you guys know.
Okay, thanks a lot, Luke.
Bye.
Bye.